Okay, let's just jump right in. What if I told you there's a tool out there that could completely reshape how we design our buildings, our parks, our entire cities? A tool that helps us build smarter, safer, and, well, more human spaces. But here's the crazy part. It's been hiding in plain sight for decades, and the very people who could get the most out of it, architects, are hardly even touching it.
To really get our heads around this disconnect, we actually have to go back in time. We need to ask a question that sounds a little weird at first. What on earth can a legendary architect, a guy known for his incredible artistry and intuition, teach us about cold, hard data? Well, the answer is hiding in one of his most famous buildings.
The story is just fantastic. So the client for this new house, a guy named Edgar Kaufman, is literally driving over to see the plans from his architect, the one and only Frank Lloyd Wright. There's just one tiny problem. Wright hadn't drawn a single thing, not a line. So in the 3 hours it took for the client to show up, Wright designed the entire concept for Fallingwater, which, is now one of the most iconic homes on the planet.
Now this is what's so incredible. Think about what was going on inside Wright's head during those 3 hours. He wasn't just sketching a pretty house. He was mentally juggling all these different layers of information about the land itself, the exact contours of the ground, the path of the stream, where every single boulder was, where the sun would hit in the winter to provide warmth, and even how cool air would drift over the waterfall to cool the house in the summer. It was just this unbelievable feat of mental processing.
You see, what Frank Lloyd Wright was doing was, in essence, acting as a human Geographic Information System, or GIS. His brain was layering all these different sets of data on top of each other to find that one perfect design. And that is exactly what modern GIS software does, but on a digital and, let's be honest, a completely superhuman scale.
So, that amazing mental gymnastics routine that Frank Lloyd Wright pulled off, we've now digitized it and scaled it up massively. This is where we shift from the human mind to the machine and really explore this tool that's been hiding in plain sight all along, GIS.
So, what is GIS, really? The simplest way to think about it is as a system for layering information onto a map. But don't just think of it as a map-making tool. It's more like a super powerful database that has a map for an interface. You can stack layers of data, like the terrain, roads, buildings, you name it, and instantly see how they all relate to each other in a specific place.
But here's the thing. Today, GIS goes so far beyond just physical stuff. Architects can now layer in data about people. Where do people actually hang out? What are the income levels in this neighborhood? Where are the hot spots for crime? GIS can pull back the curtain on all these invisible social and economic patterns, giving architects the power to make decisions based on actual, real-world evidence.
I mean, this sounds like a match made in heaven, right? A tool that lets you understand a place with incredible detail before you even draw a single line. So, that brings us to the big question we're trying to answer here. If GIS is so perfect for the job, why are architects who use it still such a rarity?
Well, the research paper that we're digging into here points to 4 major roadblocks that are basically keeping these two worlds, architecture and GIS, apart. Let's break them down.
First off, you've got a bit of a culture clash. For centuries, architecture has been driven by intuition, by artistry, by this kind of singular vision. So the whole idea of letting hard data take the wheel, well, it can feel a little strange, even restrictive to a designer who's been trained to trust their gut.
Second, architecture can sometimes live in its own little bubble. For GIS to be really powerful, it needs good data from other fields, sociology, criminology, psychology. But architectural education and research often don't build those bridges to other departments. And the third hurdle, this one isn't really the architect's fault. The world of GIS itself can be super technical. It's often focused on the nuts and bolts of the software, the how, instead of the real-world impact of using it. It doesn't always speak the language of designers or answer the kind of questions a creative person would ask.
And finally, the fourth and maybe the biggest hurdle of all, just a simple failure to connect the dots. For a long time, there just hasn't been a clear, compelling reason for how these two very different ways of thinking, the analytical GIS world and the creative architecture world, are supposed to work together.
So, how do we fix this? How do we finally build that bridge? Well, the answer isn't some new piece of software. It's a completely new way of thinking. Let's just look at the basic definitions for a second. At its core, architecture is a design process. It's about creating something new. GIS, on the other hand, is an analysis process. It's about understanding what's already there. They seem like polar opposites. So what in the world could possibly link them together?
This diagram right here shows us the solution. The missing link is research. Research is the common ground where the powerful analysis from GIS can inform and supercharge the creative process of architecture. See, GIS isn't a design tool, it's a research tool. It gives the architect the evidence, that deep understanding of a place and its people that lets them design a much better, much more responsive building.
Okay, so that's the big idea. But what does this actually look like when the rubber hits the road? Let's check out a few real-world examples of how this bridge actually works.
So, imagine you're an architect, and your job is to find the absolute best spot for a new childcare center on a university campus. You could, just look at a map and pick an empty patch of grass, or you could use GIS.
Now this is where it gets really cool. This isn't just a simple map. The analysis has layered in some very specific rules. For example, the site cannot be within 500 feet of a hazardous building, like a nuclear lab, but it must be within a short walking distance of a campus bus stop. By layering these rules on top of the map, GIS can instantly show you the handful of spots that meet all the criteria. You go from pure guesswork to a smart, data-driven decision in seconds. But the analysis doesn't have to end before you start building. What about after the building is done? Architects design these amazing spaces, but how do they know if they're actually working? How do they know if people are using the spaces the way they imagined? That's where something called post-occupancy evaluation comes in.
Using a GIS-based app like this one, researchers can do something called behavioral mapping. They can walk through a space and digitally log not just where people are, but who they are and what they're doing. This creates this incredibly rich picture of how a space is truly being used, revealing which areas are popular, which are being ignored, and maybe even why. It's concrete, actionable feedback that can make the next design even better.
And how about this for a big question? There's a famous urban design theory called defensible space. It basically argues that the physical design of a place can either encourage or discourage crime. It's a great theory, but how do you actually prove it?
Well, you use GIS to test it with real data. In this study, researchers mapped out all the incivility points, things like graffiti, broken lights, litter, in a park. Then they layered that with data on where visitors were actually spending their time. And boom, you can suddenly see if there's a real-world connection between signs of neglect and actual human behavior. You're getting real evidence to guide safer designs.
So, what does this all add up to? Where do we go from here?
At the end of the day, bringing GIS into an architect's world isn't just about adding another piece of software. It is a fundamental shift in philosophy. It's about moving away from designing based on one person's grand vision and moving towards creating spaces built on thousands of little data points, creating buildings that don't just look amazing, but that are proven to work better for the people who actually use them. And that leaves us with one last, pretty powerful question to think about. What would our world actually look like if every new building, every park, every public space was designed not just with intuition, but with this deep, data-driven understanding of the place and the people in it? What if we started building our future based on evidence?